Hello and welcome into the content video for lesson 16 for Precalculus 2. This is kind of a weird content video to film. We are going to be talking about parametric equations and eliminating the parameter. So there's not really like formulas that I give you or um, you know, step-by-step processes of what you do. So what I'm going to do is show you a sample problem, which I know it's like, oh, you do example videos. Yes, that is still coming up, but I'm going to show you how to do one, show you what these problems are all about. It'll be quick-ish, and then we'll do, what is it? I think like four actual examples in the example video. So the way these problems are going to be worded is it's going to say sketch the curve defined by the parametric equation and eliminate the parameter and it could also say and write as a rectangular coordinate equation. And what that just means is get rid of all the parameters. Just write an equation that has x and y and numbers, maybe a square root, maybe an x squared, something like that. So what does a parametric equation look like? It looks like this. We have x is equal to t squared minus 3t, and y is equal to t minus 1. So I have this new value t, and x is dependent on my value of t, y is dependent on the value of my value, y is dependent on the value of t. So what I'm going to do is set up a table like I normally would, graphs with plotting points. But now, instead of choosing values for x and y, I choose a value just for this parameter t. So let's do like -2, -1, 0, 1, 2, 3, maybe. Oops, let me move that up. So to calculate my x value, I plug this value of t into here. So I get what? I get -2 squared minus 3 times -2, which is 4 plus 6, which is 10. My y value is t -2 minus 1, which is -3. So this gives me 1 point, xy, like we're used to seeing, -3. Do it again for -1. So -1 squared is 1. -3 times -1 is plus 3. So this is 4. And then -1 minus 1 is -2. So this point I get 4, -2. Plug in 0. 0 minus 0, 0. 0 minus 1, -1. So I get a point of 0, -1. Plug in +1. I get 1 squared is 1, minus 3 times 1, so that's 1 minus 3 is -2. And then 1 minus 1 is 0. So this point is -2, 0. Plug in 2. 2 squared is 4. Minus 3 times 2, so that's -6. So again, -2. And plug in here, 2 minus 1 is 1. So I get a point of -2, +1. And lastly, 3. 3 squared is 9. -3 times 3 is 9, so 9 minus 9 is 0. And 3 minus 1 is 2. So I get a point 0, 2. Now that I have my x and y coordinates, this is what I'm going to graph just like I would have back in math 126 or whatever. Right? So I have my graph here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4. 1, 2, 3, 4. So the first point is 10, -3. So that's down here. Then 4, 1, 2, 3, 4, -2 down here. 0, -1. -2, 0. -2, 1. And then 0, 2. And so you can sort of see it. Let me do one more point, actually. Let's do 4. So 4 squared is 16. Minus 12 is 4. And then 4 minus 1 is 3. So I have another point here of 4, 3. So that's 1, 2, 3, 4, 1, 2, 3. So now, whoops, sorry, 4, 3. Now you can see this is what? This is our good friend, the parabola. So that's what that guy looks like, sketched using a parametric equation. So now, to convert it to a rectangular coordinate equation and eliminate the parameter, what I want to do in this case is solve one equation for t. So let me switch pages here. So solve one equation for t. And then once I have that t equals something, then plug into the other variable, the other parametric equation. So in this case, see if I can fit it all on the page this time. Yep. All right. So which one is the easiest to solve for t? Well, I'm hoping you're saying the y parameter, right? Because I have y is equal to t minus 1. So if I just add 1 to both sides, I get t is equal to y plus 1. So now plug this into my x parameter. So I have x is equal to t, which is y plus 1 squared. Put down a little bit. Let me zoom out a shade so you can see it. There we go. So we have t squared, which is y plus 1 squared, minus 3t, which again is y plus 1. So we can simplify this. If I FOIL this, y plus 1 times y plus 1, I get y squared plus 2y plus 1. If I distribute this -3, I get minus 3y minus 3. So that gives me y squared. 2y minus 3y is minus y, and 1 minus 3 is negative 2. And so if you remember back to, uh, actually, no, when we get to it in one of our future lessons here, when we have x is equal to something with a y squared, this gives me what? This gives me a horizontal parabola. And so this equation has to generate the same picture as the parametric equation. If this equation would have given me like a circle, well, obviously it's not correct because what I want is a sideways parabola. And that's what this equation gives me. It a sideways, a horizontal parabola. So that's how we would eliminate that parameter in that situation. And we'll look at some situations where we have to do something a little bit different. But for now, that's the general idea. We have our two parameters, x and y. Well, we have one parameter t with our two variables, x and y. We pick values for t, we plot the points, and then we eliminate the parameter, giving us a rectangular coordinate equation. So that's it. Come on back and we'll look at 4 more examples of these parametric equation type problems.